I'm typing. I'm deeply focused. I'm scripting a video as part of my course. I'm deeply focused, and then it hits me. It didn't make sense, bro. I was caffeinated. I had 8 hours of sleep, and I shouldn't be yawning at this point. Then it came to my brain. Maybe I should take a nap. Maybe a nap would be good. Maybe. Instantly, I abandoned that thought, and breath by breath, I went. Spitting on the camera, I hyperventilated, breath by breath, deep breath. Even now, I feel alert. I went deep, and now I felt energized. I was ready to work. I was ready to attack the task. I felt amazing. We've all been there. We try to work, but then we just don't get the energy, bro. Even though we may be over caffeinated, even though we may have the sleep, bro, there are days when we just don't feel like it, bro. I'm sure you've been there, and let me present to you the role of adrenaline. Now, in the vehicle of focus, imagine your ability to focus and to attend to tasks, your productivity, okay? Imagine that as a vehicle moving on the road. Now, for that vehicle to move, we need certain neurochemicals. We need certain chemicals released in the brain for that vehicle to move properly, for your focus to be centered and to be actually going, okay? Now, there's dopamine, okay, which we'll cover in another video. Now, dopamine is the fuel for the vehicle. Dopamine is what fuels you to pursue things external of the body. Then there is acetylcholine. We'll talk about that later on, maybe in a future video, but acetylcholine is the steering wheel for your focus. It is responsible for directing your focus onto specific things or broader things, okay? And then we also need some ECU, the electronic control unit, and that is orexin. Okay, orexin basically makes sure everything is regulated properly. We'll talk about that later on. I think I've already spoken about it, but if orexin activity is inhibited, so is your focus. Then we also need adrenaline, also called epinephrine, which is the topic of today's video. Now, adrenaline is the engine oil. Without the engine oil, the vehicle will not move. Okay. Now, adrenaline is responsible for making you feel alert. You know that hype feeling right now I'm getting? The horrible moves, but that's adrenaline. Okay, keeping me hype, keeping me alert. Okay? Adrenaline is released as well as cortisol. Adrenaline is also known as epinephrine, but it's not known as cortisol. Cortisol and adrenaline or epinephrine are part of what are called stress hormones, and they're released from the adrenal glands, which sit right above the kidneys, okay? Now, imagine this. Me and you are on a hunt, okay? We're hunting a saber-toothed tiger, okay? And we have our spears, okay? Our sharpened spears, okay? That has a poison tip, okay? Now, we're hunting the saber-toothed tiger, and all of a sudden, it appears from nowhere. Now, what you just saw there, okay? That visual I asked you to do, okay? What you just saw there was our fight or flight system. We spotted that saber-toothed tiger, and it was in our ability to either flee the scene, okay, run away, or attack it as much as we could, okay? What directs that? In our brain, okay? Our brain, okay? There's an autonomic nervous system which controls things like your breathing, your digestion and stuff, okay? Your heart rate and stuff. Now, the autonomic nervous system is divided into two parts, parasympathetic and sympathetic. Parasympathetic, okay, is your rest and digest system. When you're calm, when you're relaxed, okay? There's no threat in the external environment that is perceived. Then there's the sympathetic nervous system, which we're going to talk about today. The sympathetic nervous system is involved with your fight or flight response, okay? It's what gets you active and alert, okay? That's your sympathetic nervous system. Now, we need both of them. Throughout the day, we need to oscillate between both of them, okay? We need to go. We can't just be calm all the time. We can't be go all the time, okay? We need to wind down and relax. As much as we need to wind down and relax, we also need some go action. So imagine this fine balance between these two. Okay, the balance between these two is homeostasis. Okay, and that's the ideal situation. Okay, if we're tilted onto sympathetic all the time, then we can signal to our genes we can signal to the healthy genes. Okay, I'm just talking gross science here, but it's true. We can signal to the healthy genes to downregulate. Okay, genes that we need to fight diseases. We signal to them, hey, listen, I don't need you now. It's just all about survival right now. And us living this survival mode all the time is bad for our health. Okay, chronic stress, it's bad. At the same time, us being mellow and just down, that's also bad. Okay, so we need to find balance between these two. Okay, now, what I just told you, my story. Okay, I was in parasympathetic when I did not need to be. Okay, due to maybe I was over caffeinated. Maybe I didn't actually get 8 hours of sleep. But it is important to understand that adrenaline is the main thing right now we're talking about. And if in theory, okay, since adrenaline is the engine oil, if in theory we could increase adrenaline, then we could potentially increase focus. Now, under normal conditions, we cannot control our autonomic nervous system. Hence the term autonomic. It is automatic. It happens on its own in the background. We don't control it. If we could control our autonomic nervous system, then we could forget to beat our heart and we'd be in trouble. Okay? Now, under normal conditions, we can't. But by means of breath, okay, by means of how we breathe, we can directly influence our autonomic nervous system. Okay? Either tilting it to the parasympathetic side or sympathetic side. And that is the power of the breath. Okay? Now, as you've heard and witnessed, you saw me do that hyperventilated breathing. That is the topic of today's video. You saw me doing that and I woke up like a lion. I'm ready to attack this work. Okay? At the same time, if you want to calm down, there's this Dr. Andrew Huberman, okay, explains this connection between heart rate and breathing. Okay? Now, the connection between heart rate and breathing is called respiratory sinus arrhythmia, which, if I was to boil it down and make it as simple as possible for you, when you inhale, your heart rate increases. So the more dramatic and vigorous the inhale is, the faster your heart beats. Okay? When you exhale, your heart rate decreases. So the more intentional and vigorous and longer the exhale is, the slower your heartbeat goes. Okay? With ventilative breathing, we focus more on the inhale and just let the exhale come out. So this causes a shift in our heart rate, favoring it to be beating fast. Okay, this makes our heart rate beat fast. Okay, so we can control our heart rate in the sense by means of breath, and that signals to our sympathetic system that, okay, bro, there is a threat outside. We need to get this human pumped up and jacked up on the stress hormones, adrenaline, cortisol and stuff. That is good. Okay, that is good here and now. Okay, because we got work to attend to, bro, and we don't need to be in this parasympathetic right now. Maybe later on, after the work is down and we can calm down and stuff. But right now, we need sympathetic action. And how do you do that? By hyperventilated breathing. Now, here are some precautions. Don't do it when you're seated in a body of water, because you might pass out. That's just how intensive this is. Okay. At the same time, when the breathing, the practice I'm about to give to you is, so for 30 times, so that's one. Okay, you do that 30 times. Then on the last breath, you take a big inhale in, hold, but don't hold too much. If you hold too much, you run the risk of passing out. Okay? Because what you're basically doing here is you're expelling all that carbon dioxide. Okay? You're expelling all that carbon dioxide. And you're making your blood more alkaline, okay? Therefore, suppressing the need to breathe, okay? When your blood becomes, do you know that the pH of your blood is what triggers you to breathe and not breathe, okay? So, with this practice is called Wim Hof, okay? And I do it before every focus ritual. It's my focus. It's my ritual before any cognitive bout. I do it. I didn't do it now because I needed to get this work done, but It's my ritual, okay? Now, I'll just explain some physiology behind this here. The pH of your blood is what triggers you to either breathe or not breathe. When your blood gets acidic, it signals to your brain picks up on that, and it causes you to breathe in. Take an inhale, okay? Now, when you do this, and then you hold, you're expelling all that carbon dioxide out. Okay, oxygen does not change. Your blood oxygen levels don't change much. You're expelling all that carbon dioxide out. Okay, your blood is alkaline, and you don't have that activation to breathe. You understand? Because your blood is alkaline. Okay. Now I'll leave a link in the description or on a Wim Hof practice that I do every day. It's a guy called Breathe It Standy. His music is nice. He plays such music in the background. Wait. There's this music, hand pan music. Okay, if you love that type of stuff, I'll leave a link in the description, and he'll direct you to breathe in 8 minutes, bro. Before every cognitive task, you'll be good. And by the way, don't hold too much when you're on that. And then hold. You don't hold too much. Like, don't squeeze the low because, bro, you'll pass out. Okay. And yeah, do that before every cognitive bout, and you will get an adrenaline boost, and you will eliminate all that sluggy feeling you get. Okay. Over. By the way, before over and out. Okay, before over and out. Scroll down. Okay, scroll down. If you want more people to meet, like, if you want more people just like you interested in optimizing their brain for focus. Okay. If you like the way I speak, if you like the information I'm giving, bro, don't hesitate. Hit that red button. Okay, subscribe. It helps me, makes my day, keeps me motivated, bro. Over and out.